carrying on with 18.1, there is only an 18.1, there is no 18.2, it just goes into the assess after this. Anyway, this is question 7. Don't be scared of it. It says an isosceles triangle has two sides of length 7.5, so that's 7.5 and so is that one, so let's just put it in there. And it's got another side of 12. Now they're very kind, they drew the right angle there for us. I've got to calculate the height of the triangle, the little h thing, and give my answer to 1 dp. So look, focusing here on this part of the triangle, if it's 12 across the base, then actually the part we want is only 6 centimeters long from there to there, alright? Excuse the wobbly line. So I've got a 6, I've got a 7.5, which is the hypotenuse, the long side, the mummy side. I can work out the height of this isosceles triangles, and basically it's a straightforward Pythagoras thing. So ignore this side, let's just work on this side here. So what have I got? Let's do it properly. I've got the height squared, which is one of the babies, plus the 6 squared, which is the other baby, will make the hypotenuse squared, or the mummy square. Alright, straightforward. So h squared is going to be 7.5 squared, take away the 6 squared. You know that when you're trying to work out one of the little ones, it's a takeaway, right, rather than an addition. So the height squared is going to be 7.5 squared. That gives me 56.25, and I know 6 is a 36, so my height squared is going to be 56.25, take away 36, well that's going to be 20.25 actually centimetres squared, but anyway, we're not actually working out an area here. Therefore the height itself is going to be the square root of that, and therefore the height is going to be, bam, 7.5 exactly. Now that's impossible, I reject that. I totally reject that. So 20.25 square root of 20.25 equals, that's better, press the wrong button, so 4.5. I mean, I've got an answer of 7.5, I don't know what I was doing. So there's no way you can get a height it's equivalent to the hypotenuse. The hypotenuse is the big one, and therefore by definition anything else attached to the triangle will be less than 7.5. So that's that. H is 7.5. Beautiful, very, very easy. Now here's an application of Pythagoras. If we have a point A, which is, there it is, 2, 3, and the point B, there it is, 5, 7, we can use Pythag to work out the distance between the 2 points on a grid. In other words, the length of the line segment. Now look, from 2 to 5, the x value, we have a spacing of 3, a distance of 3 units, and from 3 to 7, as you can see, 3 up to 7, we have a spacing of 4. So essentially we've got ourselves a little baby Pythag, haven't we? We go 3 units across there, 4 units up, and therefore that was the point A, that was the point B. I can now work out the distance here, which we call x. Same thing, you can do it now. So we're finding the big one, aren't we? So 3 squared plus 4 squared. Many of you know the answer to this straight away, because 3, 4 is very famous. 9 and 16 comes to 25, and the square root of 25 is of course 5. Alright, so the length of that line segment is 5 units long, or centimetres, whatever it is. And we can do exactly the same with these coordinates as well. We can do a little sketch. I want to show you that we don't need to do a little sketch. I want to just do this one as a demo here. So here we go. From 3 and 7 are the x, aren't they? So let me just draw a little triangle, like so. Between 3 and 7 I've got an x space of 4 units, fair enough. And from 5 to 8 going up, I've got a y space of 3 units. So I know this looks longer than that, it doesn't matter. An x space of 4 and a y step of 3, say, and it's still a 3, 4, 5 triangle. So I shouldn't have chosen that, should I really? Anyway, so here we go. X squared, same as before, nothing new there. 16 and 9, 25. Press the square root button. Of course that will give us an answer of 5. Now let's just do a better one. We'll try that one now. a little triangle down here will be fine. I've gone from 0 to 5, so over to here, so it's 5 units across. I've gone from 4 up to 10, it's like going 6 units up. So I've got a 5, 6 triangle there. Of course all these are right angles, like so. Now we're going to do the maths on it. X squared equals 5 squared plus 6 squared. 25 and 36. 50, that comes to 61. Press the square root button. And that will give us something to one decimal place. What does it want? 1dp? Can't read it from now. Anyway, I'm going to go 1dp maximum. So square root 61 is 7.8 units long. And I may as well do the last one because I've got the time for that. So another triangle. From -2 to 1. So from -2, so come back here somewhere, -2 up to 1, we've gone 3 units across. And from 7 up to and from 3 up to 7, we've gone 4 units up. So that's really, really dull. It's another 3, 4, 5 triangle. So straight away I know my answer is 5, and I'm not going to worry about that. I'll just pause for now and have a spot check on that. Yeah, they're all silly, crazy answers. All 5s apart from that one. Very boring indeed. Right, next question. Right, this is question 10. It's got a little star by it, like question 9 had a little starry thing by it. Doesn't need to be. Look, it says find the length of the side marked X of each diagram. Right, this is Pythagoras, don't forget. I need the baby to get the mummy, but I don't know you. Therefore, I've got to get you first. Let's call this something like, I don't know, little a to match the question. So if I know 11.6 and 10.5 are the two smaller sides, then A would be the hypotenuse of this triangle here. Once I've got A, it becomes the small side of this triangle here, because X is the big side. How do you know? It's opposite the right angle. So let's just get A first, shall we? So A squared equals the two little ones squared for this triangle. We'll do that first and get some answers. So 10.5 squared is 110.25. Don't go glitchy now, please. I'm trying to finish. Come on. And then we got 11.6 squared is going to be 134.56. Add them both up. Comes to 244.81. So A on its own will be the square root of that, 244.81, and that will give us an answer of 15.65, say, and that will be in centimetres, and clearly that's the bigger side. Now let me just substitute that in there so I can use it for my second part, which is to work out X. So here we go, the shorter side now of this bigger triangle. Well, they're not bigger, it's got a longer hypotenuse, that's for sure. So this is now the short side, 2.3 is the short side, and now I'm going to work the second part out. So here I go. X squared is going to be the 15.65 squared plus the 2.3 squared. Now, I know the 15.65 squared originally came from this, so I'm just going to write it down. So it's 244.81 plus, well, let's just do 2.3 squared now, 5.29. Add them both up. Oops, do it again. 244.81 plus the 5.29. Yep. Bam. 250.1. Okay, 250.1. To get X on its own, just hit that square root button. Again, don't bother cancelling on your calculator, just hit the square root button now. Bam. Now equals, yeah, 15.8. So X is 15.8 centimetres. Done. That's that one. Hopefully I've got space to do this as well. I've got to find X, so let's just talk around it. Well, X is the shorter side because 29 is the long side because it's opposite the right angle. I need to know that length there. Fine. Well, look, if that's a right angle, then look, so is that. So there's my 90-degree angle. So I've got a short side. This is the short side I need to work out in order to get X. So the 31.4 has got to be the longest side. Alright, so this is small, this is small, this is big. Let me call it B. So let's do it the proper way. 31.4 squared is basically this baby square plus the 15.2 squared, right? So we take the 15.2 next door and subtract. That's how we do it. So to get the little baby, 31.4 squared minus 15.2 squared. Work that little bit out. 31.4 squared equals, that's 985.96. Let's take away the 15.2 squared. That's 231.04. Let's just do a subtraction now. 985.96 take away 231.04 equals, right, we've got 754.92. Now we're going to hit the square root button of 754.92. I'm going to squeeze it in the corner here now. Square root, bam. We've got 27.48 to 2 decimal places. So I'm going to use that now. 27.48 is obviously smaller than 31, so I did do it around the right way. So now I have a small side, a long side. So here I go. Let's try and squeeze it over here, I think. So x squared is the small length, so we're going to do 29 squared, the hypotenuse, take away this 27.48 squared. Now 29 squared I've not worked out yet today. Gives me 841. Take away now this 27.48 squared is basically this 754.92. Or is it 96? Yeah, no, 92. Work this out now. 754.92. That gives me 86.08. And now we're going to hit that square root button like so. And we get out on our marks, all of them. Bam, thank you. Let's call that 9.28. Could call it 9.3. Depends what the answer book says anyway. An exam will specify. I can go to 1DP certainly because of that. So 9.3 is good enough for 9.28 because I can't bother to do it any further. Right, and that's of course in centimetres. No, I lied, millimetres. Sorry. Just scrub that out. Put some millimetres there. And that's it. I'll stop there and I'll look at the assess in a second.